Hi, and welcome to Chapter 13. We're getting into File I/O, or File Input and Output today. You're going to hear me say I/O a lot, and that's what it stands for, Input and Output. We're going to get into how to get a file, read a file, write to a file, stuff like that. So let's get started. The first thing we're going to talk about is understanding how computer files get stored on the computer. This might be review for some of you. You may already know this, but no harm in doing it again. First thing we talk about is volatile storage or temporary storage, stuff that goes on your RAM. This is your random access memory, your RAM that you may have 4 gigabytes, 8 gigabytes of RAM, something like that. This is the temporary stuff where things get put but not actually saved. So if your computer gets shut off or if the program gets turned off or something like that, those files are gone. Everything's gone from that. That's volatile. It just changes whenever the power goes out or something gets turned off. So we use volatile memory a lot because we're constantly creating variables, removing variables, doing things like that, and that's all going into your volatile memory. It's not going onto your hard drive right now. The other is what we call non-volatile or permanent memory. This is saving to your hard drive. So when we do this, we save a file that you can go back and get later. So it's really important to be able to have non-volatile memory because you want to be able to store pieces of information that you can access after the program's been shut off. So you run your program, you add stuff, then you turn it off, you come back the next day, and you have to re-enter stuff. Well, that's lame. You want to be able to store it on your hard drive. So we're going to store it in non-volatile memory or on your hard drive, onto your disk. When you save to disk, your text files can be read by any text editor. So you can open up Notepad and you can read your text files. Those are TXT files. You can also store files in binary format. Those can include images or compiled programs. You're not going to be able to open those in Notepad. They're all in binary, so you can't read them directly. Generally, when we talk about storing files, our root directory is our C drive. So it'll be a C:\\, that's your C drive. You may have most of your files in your My Documents section of Windows, which is going to be something along the lines of C, and then user, and then your username, and then documents. So it depends. You want to know where your files are because it's going to be really important to be able to create a path so you can go find them. What you're going to be doing is creating files, and then you have to go into your Windows Explorer and go find the files. Make sure you know where they're being put. So we're going to talk about how to deal with your path and make sure you know where you are. When you work with your stored files, generally people follow the same basic structure of first you have to find out whether the file exists. Does the path exist? Are we trying to get something that doesn't even exist? Okay, now we know it exists. Then we open the file, we write something to the file, or we read something to the file, and then we close the file. Sometimes we're also going to delete the file. So if you want to have a temporary file that you go in and delete when you're finished with it, you can do that as well. Okay, so that's the basics of computer files. Let's keep going. When we have path and file classes, in Java, we refer to our classes as either a file class or a path class, and they can tell us different pieces of information. We also have a file systems class that tells us things about the file system. So a couple of different classes that we're going to be using. Most of these exist inside of the Java new input output or NIO and then file. So our java.nio.file, and then we have a couple of classes inside of there, just like our Java utility swing, something like that. Our path class is going to give you information on your files and directories, including the location and the size and whether they exist. So when I say you want to check whether your file exists ahead of time, you're going to use your path class to figure that part out. It also allows you to say, here is a file, where is this file, so I can get reference to that path in my code. The files class does actions on the file, including creating the file, deleting the file, and then doing input and output streams to either add stuff to the file, to write to the file, or to read stuff, input streams. When we want to create a path, we can use the file systems get default to get the default file system. And then you can figure out where that is. So you can call file system.getPath to find out what the path location was of the default path. It might be somewhere really weird for you. It may be inside of some apps directory that may be hidden. It may just be in your My Documents. I don't know. It'll depend on your computer system how it's set up. So you're going to want to use the get default so you know where those files are. An important thing with file systems, your double slashes go between your directory locations. So when we do C:\\, it isn't just one, it's two, because we need to escape that backslash. The other option you can use is what we call fs.getSeparator, and that will go get the double backslash separator for you. By using that, if you use this on a different file system that is not Windows, it'll work there as well, because it'll get the file system separator that needs to be between your file folders. The other way that we talk about paths is either absolute or relative. An absolute path generally starts with what drive you're using, C:\\, and then a couple of directories. Again, it could be users, your name, my documents, and then Java or my class or CSCI 111, whatever it is that's going to be your directory. And it's going to have that full path with the whole C directory and everything else in it. That's absolute. So you can use that no matter what directory you're actually in, a full path will go find it. Relative assumes that you're already in the current folder and it only looks in subfolders. So if your current directory is your My Documents directory, your folder, then it's only going to look underneath that, or it's only going to add things in that directory and below that. It's not going to look at everything. So absolutes can start with a file name directly. It doesn't have to have anything in front of it if it's no path if you're in your current directory. It could also just have one directory down, like chapter 13 / data.txt, and it'll put it in that current directory, and that way you don't have to have that full path. Remember, with a relative path, if you are not in the right path when you start, it's not going to be able to find the file. So if you are running this in VS Code and your current directory is not where you think it is, you're not going to be able to find your folders or your files. So make sure you check to find out what your path is for your current directory before you start saving things as relative. Couple of path methods. We have a toString. We like to toString things, so we have a way to print our path. We have our get file name, we have our get name count, and we have our get name. So a couple of things that you can do with your path to get some pieces of information. Okay, let's talk about file accessibility. How do we know if a file exists? How do we know if I can use it? You have to use some pieces of code to make sure that that file that you're trying to write to actually exists. Or if you want to create a new file, does the file already exist and am I about to clobber it? So to use the methods that are available, we have a Java new input output NIO file, and then we have an access mode package. And that has a couple of things in there like check access. Does the file already exist? We can also do things with parameters to say that I want to open my file as read or write or execute to see the options that are available. So I can do that with my check access methods to make sure that I have access to actually read or write this file. Some of the files on your computer you may not have access to read or write. Generally you should if it's your computer, but if it's someone else's, if it's the school computers, you may not have read or write access to that directory. So it's important to check to see whether you have read, write, or execute access to the directory you're using. If you want to delete a file, such as I've created a file and I want to delete it, there's a couple of things that could come up. You could have errors such as no file. File doesn't exist. I'm trying to delete something that doesn't exist. I'm trying to delete a folder or a directory that is not empty. So that makes the computer very unhappy. It looks at it and goes, hey, there's stuff inside this directory. You don't really want to delete it, do you? So it gives a directory not empty exception. It also runs security exceptions like you don't have permission, or IO exceptions. You entered the file folder wrong, you entered the file wrong. There's just something that's IO that's wrong when you delete a file. But the method to delete is just file.delete. And you can just do that. You want to be very careful when you're deleting files. Deleting files can be bad. They go right away. There's no check. There's no, oh my gosh, am I sure I just wanted to delete my whole file? Don't delete files unless you're really sure you're ready for that. There's also some attributes. You can get the file attributes for the file you're working with, such as what time was it created, when was it last modified, what size is it. These are pieces of information that might be useful to you when you're checking to see if the file is the right file, if it's what you wanted, so on and so forth. There's a couple of little example codes here that I have on the side that just show you things that you can do, and then some catching, some exceptions. Remember, we did exception handling. I expect you to catch your exceptions. So if I'm going to try to go get this file and I want to delete it, how do I know I can? Did I check all of my exceptions and make sure that I handled those? Because when I check your code at this point, I'm going to be putting in stuff that's going to make it crash. I expect to be able to catch those exceptions. Okay. When we talk about organizing our files, it's nice to remember that the smallest amount of data that you're going to be able to use is a character. Yes, technically you can use a bit. 8 bits usually makes a character. Yes, you can do that, but a bit doesn't tell you anything. You can't do anything with a bit. So let's just look at characters. You can do individual characters. You can do a field of, which is just a group of characters, like a string. So that would be like a field. We're getting you prepared for databases. After that, you would have a record, which would have a series of fields. So in this case, it has an ID field, a name field, a last name, first name, and then some sort of a dollar amount. So that would be an entire record. A file is a collection of records. So you can think of it as an array of records. Each record is an array of fields. Each field is an array of characters. That's how things get stored on your file. So when we look at our file, that's what we can see is the breakdown of fields and records all inside of a file. When we're looking at individual file types, we have 2 different types that we're going to talk about. The first is a sequential access file, where each record is accessed directly after the other. So if you're going to look at your file, you're going to be able to see a record followed by another record followed by another record. When we get the files out or the records out, we are getting them one after another in sequential access. Each record is accessed one right after the other. The other is what we call a comma separated values. Each value is not separated by spaces. They're separated usually by a comma or some other delimiter. A delimiter is something that separates your line into individual items. It could be dashes, it could be exclamation marks, it could be pipes, could be ampersands, whatever it is you want to use as your comma separated delimiter, or your delimiter for your file. Usually people use commas because it makes more sense. It makes it easier for you to view it. But if you've got commas in your field, like if you have a text field that has a comma in it, you're going to want to use a different delimiter because comma's not going to work anymore. We try to avoid putting commas in our data fields for that purpose exactly. When we look at our files, that way we can go through and get an entire record, and a record is going to be a series of fields separated by a comma, which we can then use a split command to create into an array of fields and then use each individual field. We're going to talk about that in just a second. When we talk about our file, if you guys remember when we opened up our data stream to use our scanner, I always kept saying you need to close your scanner. Really, really important with a file that you close the file. So file management, you open the file, use the command open to open a file. You can access the file via what we call a stream, input and output streams. We'll talk about that a little bit. And then we close the file. In some of our files, we want to also make sure we flushed the buffer. So if there is a buffer that is kind of a tube that is connecting the file to your code, you want to make sure that that tube is cleared out before you close your file, because you want to make sure all the fields got put in there, all the data got put in there. Now, when we talk about streams, we have been doing input and output streams all along. Your scanner uses system in, which is an input stream. When we do our system out, we are doing an output stream. So you already kind of have been using streams this whole time. We're going to use different types of streams. These are going to be file I/O streams instead of console I/O streams, but it's still going to be next line or read next or read line, similar to what we've already been doing, write line, write. So we'll talk about those in just a second. All right, so this is some of Java's I/O class methods. I want to make sure that you understand them and what they're called and how they're used. In this case, you can see that we have imported that nio.file package directory library so that we can get to it. We also have included a static Java file standard open option just to make it easier for us to open our files. Just an extra little thing that we use. Okay, you're in your main. You want to go get a file. You're going to call the path file. So the file is a type of path. And it's going to be go get the path at this location. When we do that, we have a directory or a location of where our file is located. You're not going to be doing things to your file directly yet. We're going to do those in just a second. But right now, all we have is a path. Where is it? So think of it as I'm holding on to the directory in my hand, and I'm going to use that. In this case, we have a string, A, B, C, D, E, A, B, C, D, F, their grades. When you have a string, if you want to put it in a file, you have to get the bytes. You have to get the individual bytes of your string. You don't want to just try to put the string directly in. Depending on which method you're using, some methods will let you do that, some methods won't. So if you need to use a byte array, this is how you would create a byte array. It's an array of bytes, just like an array of integers, and that's where your data is. And then we use the method getBytes off of our string. And it's already included in your string method. You just have to say getBytes, and it'll get you a byte array that you can then put into your file. In this case, we have our output stream that is just set to null to begin with, because we're going to do this a couple of times. We're going to do it in a try loop, and we want to make sure that we have access to that variable, but we're not going to set it to anything yet. So in the first line of our try loop, or our try catch block, we're going to say that the output equals a new buffered output stream. Okay, so a buffered output stream means that we're going to have a stream that is going to go to the file location, and it's going to buffer them. So it's just going to take the pieces of information and put them into the buffer, and then it'll add them to the stream or to the file as it can. But it's not going to wait until everything is added. It's going to let you keep going with your code. It's buffering it. It's just kind of letting it sit there. If you've watched Netflix movies and it's buffering, it's trying to load up the new content quickly, and it's trying to keep the future content buffered so that if your internet connection goes down or something happens, it's all sitting in the buffer waiting for you. So hopefully you understand the concept of buffering. In this case, we're going to do a buffered output stream, and we are going to use our files class, and we're going to create a new output stream from our file. Remember, our file is our path. So where is the file? The file is at chapter 13 grades.txt. It's an actual file. And we're going to call it with the method create, because I want to go create the file. The file hasn't even been created yet. So I'm going to do that. And then with that buffered output stream, I'm going to call the method write. I'm writing to the output stream, and I'm writing those byte array, that byte array of my data, A, B, C, D, F. I'm writing that into my output stream. At the end, I'm going to flush my output stream. What that does is, if you think of an output stream as a tube that has all of your data in it, and it's pushing data in like this, there might still be data sitting in there. So flushing it just flushes it all out, make sure all of it gets into your file before you close your file. Then I'm going to close my output stream, and now my file is all set. All the data has gotten into my file, and I should be good. At this point, if I had any exceptions, I could catch those, and then I can move on. So this is a basic write to your outputs through an output stream into a file. So we talked about an output stream, and we talked about how to write to a file. Get the path, create the output stream, write to your data, flush and close your output stream. Now we're going to go talk, or on the next slide, we're going to talk about your input stream and your readers, because those are two other things you want to be able to read from your file. Okay, so this one is reading from your file. This is the second half of your I/O that we talked about in the last slide. When you read from your file, you are going to create an input stream. The same way we create an output stream to push it out, we're going to create an input stream to get it in. In this case, we again get our path of our file. You've got to get a path. It has to know what a path is. So you can go and get your path. So what directory location am I looking for? Then you're going to use your files class and our new input stream method. This method is going to take that file, and it's going to turn input into the input stream coming from your path. We've worked with input streams before, but in this case, we're also going to be working with a reader. So we have an input stream, which would be similar to your scanner, your system in that we used there. But in this case, instead of adding a scanner, we're going to use a buffered reader. So instead of a buffered writer, we're going to use a buffered reader. And we're going to create a new buffered reader using our input stream reader input. So a couple of little levels there. Input stream is the raw data coming from your file. I need to make an input stream reader to read the data from the raw data. And then I'm going to create a buffered reader to buffer that information. Again, if your files are very, very small, you probably don't need to buffer them, and you could just use a regular input stream reader. That's not really a problem. But using a buffered reader makes sure that you can handle your code being really long. In case there is a lot of information in there, you want to use a buffered reader so that you can get that information and start using it right away. So we're going to use our buffered reader. In this case, we're going to create a string. It's not going to be anything. And we're going to set our string equal to our reader read line. And it'll get the next line from that reader. We're going to system out. So we're going to print to the console whatever we just got in. And then we're going to close our input stream. So you see how we have input close there. This is why I wanted you to get in the habit of closing your scanners, because you'll get in the habit of closing your input streams. If you do not close your input stream, it creates this memory leak that becomes a significant problem in your code. You'll start to just have memory leaks all over the place, and everything will run slower. You've got to close your readers. So in this case, your new input stream, we've got to close that. And again, we have a catch in case there's any IO exceptions. So reading a file, go get the path, create your input stream, set the input stream equal to new input stream, create a reader, then be able to call read line on the reader. Close the input stream when you're done. In this case, we only had one line, so we didn't need to do very much. But you might be throwing this inside of a loop because you might want to be getting a lot of lines. If you have a whole subset of records in there, you're going to be wanting getting all of them. So you're going to want to be doing this in a loop, some semblance of read line, read line, read line over and over again until you get all of the data that you need. There's a couple of methods up at the top there that can just describe the different things and what they do and how you can take parameters for them. Okay, let's go on to the next one. A lot of what we've talked about so far is putting a single line into your field or into your file. In this case, you're going to be having a lot of fields or a lot of files. Lot of records. So you're going to be creating and using what we call sequential data files. Essentially, it's large amounts of data separated by new line characters in your record. So here's a record, here's a record, here's a record, and they're all in this thing together. And I'm going to have to do some semblance of a loop to get them all out. You're going to want to read from and write to files in sequence, usually one right after another. I want to write all of my files. So I'm going to write line after line after line. So I'm reading through my array and I want to write each array. Each entry in my array, or I'm going to read and I want to put it into my array. So you're going to need some sort of a loop with some sort of a sentinel to get and write all of your information. In this case, we have done a while loop, and in the first subset of code, we are asking the user to enter information with a sentinel, and in the second piece of code, we are going through and reading lines into our string. And then we're splitting our string and getting the piece of information out. So the first set over there is going to be your writing, and the second is going to be your reading. And you can see the little output over in the corner is the output of the reading. It went through the array and it split the string with a delimiter. We haven't really talked about the split method because we haven't really needed it yet, but the split method on a string will allow you to split your string into an array separated at wherever your delimiter is. At this case, we made our delimiter something like a comma or a, I don't know if we did our delimiter. Oh yeah, we made it a comma. And so what it's going to do is it's going to take that whole long string, name, comma, last name, comma, birth date, comma, whatever, and split it into an array where index 0 is going to be the first name, and index 1 is going to be the second name, and index 2 is going to be birth date, so on and so forth. So in this case, they've made name, pay rate, and ID are your three values that are going in there. And then we were able to print them out and do a little bit of math and make it all lovely. So you put stuff into a file, got stuff out of a file. The great thing, of course, with files is when you shut down your computer, the file's still there. You can read it again next time. Okay, so those are sequential data files. Let's move on. All right. Sometimes we would like to use random access. So a random access file allows you to access your records in real time, getting a specific record, going to a specific place in your code or in your file and pulling out something specific. So in this case, we talk about batch processing, which is the same task with many records in one big group. So we did a big for loop and we added all the records. So there was 100 records, we added them all. Then you have what's called real time, which is accessing the record when the user asks for it, And the user has to wait while you go get it, which is fine. That's what we do a lot. And computers are so fast now, that's not as much of a problem. When you make an interactive program, the user makes requests in real time. That's how we normally do things these days. It used to be you would make a request, go home, get a cup of coffee, come back the next day, and you'd go get the data then. But everything runs so fast, we don't have to do that anymore. And then random access files is where the records can be retrieved in any order, as opposed to pulling the first record, then the second record, then the third record. It gets any record at any time. So it's called direct access or instant access, where you can go and get a specific location in your file. To do that, we can use what is called a file channel. So a file channel class is it's in your Java docs. You can go look it up for more details on it. But a file channel class will allow you to go get a piece of information from a specific location in your file. So to create a new file channel, we create a new byte channel from the file, and then we can go to a specific position in the file. So if the file is 400 words long, I can go get the letter at 400 letters long, characters long. I can go get the character at line 20 or at position 20 or the position 40 or any specific position that my file channel can go move to. So you create a buffer to wrap the data, and then you send it to the file channel. So we talked about buffers. So in this case, we made a byte buffer that we wrapped our data in, and then we sent it to the byte channel. And then we were able to move around in that byte buffer and access each location using the position, which is the byte offset. The great thing with file channels is they let you go forward or backwards or left or right or up and down. They let you move around. Normally with streams, you just go straight. So you start from the top and you go all the way to the bottom. Okay? All right. Okay, so let's talk about how to write records to a random access data file. So how are we going to write records? In this case, we're going to have a file that has 10 different records in there, and we want to enter the second record. So we want to go to a specific place in our record or in our file that is the second record. To do this, you can use your file channel, same way that we talked about in the last slide. Create your string of how long a record is supposed to be. In this case, all of our records we are saying is a given length. In this case, it's a 3-digit character for our ID, 7 digits for our name, and then 5 digits for our salary, and then a new line. So all of our records are exactly the same size. By the way, this is assuming that your names are all 7 characters. You might have to fix that by making a maximum of like 30 and then using a buffer to add spaces so that if you put in a 10-character name, it would buffer and add 20 more characters to the end to make it a total of 30. So we're going to assume for this case that our record size is always the same. It's always the same length. So what I can do is I can go get my path, write my string of my new line that I want to write in there, and get my record size, which is going to be the length of my string, because all my strings are the same length. I'm going to create my data array, and then I'm going to get my buffer to wrap that. I'm going to go open my file channel into a new byte array for this, and then I'm going to go to the right position, which is my second record down, or 2 times my record size. If my record size is 15, I need to go 2 times 15 or down to position 30, which will be the start of record 2. Then I can go ahead and write my buffer, which is the string that I'm going to be putting in there, and it'll replace what was there with the new string that I'm asking it to do. Then I can go ahead and don't forget to close your file channel, and you can move on. And now we've just added our second row to our data with our write using our random access data file. Okay, so that's how we would write files in this case to a specific location. Let's talk about reading. When you want to read a file from a random access data file, again, go get your path, initialize your byte buffer that you're going to use to wrap the data. The data, again, is the bytes that are in your string. In this case, we have our string of our 0, 0 and our line separators, and we've added that. So we are going to go ahead and add the stuff that we need to do in our system. In this case, after we've added our pieces of information, we want to go read. So we're going to have a sentinel, some sort of a quit, and we're going to walk through and we're going to say at this position, what was the data there? So we're going to set the position of our file channel. We're going to read the channel into the buffer. Then we're going to be able to set our string equal to the new data that came from that buffer, print out the string, get a new ID, and go find it. In this case, we found the specific ID because the ID was going to tell us where we wanted to look in our system. So we asked our user, what ID number do you want? And they're going to say, I want ID number 5. And we're going to say, okay, cool, that's the 5th record. We're going to go down to the 5th record and we're going to pull that out. And it lets the user keep entering in new IDs where we can go get new information. So this is kind of a loop using a buffer to get our data out of our access file in specific locations. Don't forget to close your channel at the end. All right, so that was our quick and dirty version of file input and output. What I would really, really recommend is that you spend a little bit of time going through the book and doing the exercises that are in the book. It'll just get you used to typing in the letters that you need to do and the words that you need to use, using that file class, the path class, and go in and get it to say hello world and then come back. Did it actually write it to the file? Were you able to read from the file? Then try a couple with records. It's going to help you on the homework because the homework is going to assume that you can do all of that. I didn't add a you do it to this project. I should have. Just because I wanted to make sure you got all the information kind of in sequence. I didn't want to stop in the middle. So I would like you to spend a little bit of time going in, make a file that says hello world, and then read it back in. Make a file that adds 3 records, read them back in order, and then have the user say which one do you want, 1, 2, or 3, and go get that specific record. If you can do that, the rest of your homework will be a lot easier. Things to remember. The path name might be relative and you may have to make it absolute before using it. So if you have a path name and it's relative and you're not in the right directory, you need to make it absolute before you start using it so you can change it that way. And remember, the escape sequence for separators is 2 backslashes, not just 1. If you just do 1, it'll be an escape character and everything will get confused. You need 2. Okay? Let's talk about your homework assignments. The first assignment is number 6. Okay, in this one, you are going to create an accounts numbers in text file. It's similar to the one over on the side there. I think there's like 10 in there. I don't know. I think the assignment says make 15. Put in a couple of account numbers. Then you're going to validate those numbers by writing a program that reads in each account number and displays whether it is valid or not. Okay, whether or not it is valid is determined by if the last digit is equal to the remainder of the sum of the first 5 digits divided by 10. Okay, yes, that's a lot of math. You can do this. So 223355 is valid because the sum of 2 plus 2 plus 3 plus 3 plus 5 is 15, and the remainder is 5, which the last digit is 5, so that was fine. So you're going to look at the first 5 out of the 6 digits, and you're going to add them all up and then do the remainder, so modulus on it, find out what that is, and compare it to whatever the last digit was. If it is not valid, you have to say it's not valid. At the end, you're going to write only valid account numbers to an output file, each on its own line, with a file named account numbers out.txt. So you're going to have account numbers in with, say, 15 or 20, where some of them are invalid, and you're going to have the computer, the program that you're going to write is going to create account numbers out, which only prints out the valid numbers. So you might have 10 of the 20 or 10 of the 15 that are valid, and that's okay. But you do want to have at least some. So this is practicing in and out and throwing a little bit of math in the middle. Let's move on to exercise 8. Exercise 8 creates an application that allows you to enter student data that consists of an ID number, first name, last name, and a GPA. So this is just the list of all the students and their names and their ID number and their GPA. Then your code is going to read in that input file. It is going to look at the GPAs, and if the GPA is above a 2.0, then you're going to output that person to the student's good standing text. If their GPA is below a 2.0, you're going to put those into a file called student academic probation text. Think of this as you're working at the school and you have a list of all of the students and all their GPAs, but you need to know who is on academic probation and who belongs on the dean's list. So who's above a 2 point and who's below a 2 point. You need to make sure you get all of the students into one of the two files. So if you start out with a list of 20 students, you should make sure that however many are in your good standing and how many are in your bad standing, that total equals your 20. You're not asking the user for this input. Unless you want to. If you want to do user input for all 20 of these people, you can. You can also input from a file so that you don't have to type it multiple times. I like putting things in files because when I'm testing, I want to run the same pieces of information multiple times, and it's good to have a file to read from rather than just having to type. Again, your choice. Please let me know if you're going to need me to enter the data, just because then I'll make an input file and use that. Okay, so those are your 2 homework assignments. There's only 2. I wanted you to be able to get through File IO. Because we are coming up on the end of the semester, I am going to open up chapter 14 on swing early. So I would highly recommend this week that you do your chapter 12 and chapter 13 quickly, so you can get started on chapter 14 quickly, so you can have lots more time to work on your final. Okay, have a fabulous week. Call me if you have any questions, and we'll talk soon.